is Operating System Labs exercise number 10, scheduling algorithms. So we're going to be looking at two different types of algorithms. One is going to be first come first serve, and this is shortest seek time first. So first, for this exercise, for shortest seek time first, I've defined a few functions that we're going to need. One is calculate difference. We're going to pass q head and a variable diff. For I in range of the length of difference of I0 is equal to the absolute length or absolute of q of I minus head. In this function, find minimum, we're going to pass the difference, and index is equal to, initialize index as -1, minimum as a big number. And for I in range of the length of difference, if not difference of I comma 1 and minimum is greater than difference of I comma 0, both of them are true, minimum is equal to difference of I0, and index will be initialized as I, and we return index. Now in this function, shortest seek time first, we pass the request and the head, and if the length of request is equal to 0, we return. Then we've initialized L equal to the length of if it's not true, L is initialized as L of length of request, and difference is initialized the value of 0 into 1, and we're going to initialize the array. So for I in range of L, difference of I is equal to 0, 0. Then we count the total number of seek operation. Now we're setting that as 0, and now we're going to store the sequence in which the disk access is done. So seek sequence variable is equal to 0 in the list, the index value is 0 into length plus 1, L plus 1. Then for I in range of L, seek sequence of I is equal to head, calculation difference, we're calling the function, and we get the index. We're going to assign the index, and we're calling the function find the minimum, we're passing difference, and we return the index, and we're passing that in the variable index. And then a difference of index of I is equal to 2, and then we increase the total count. So seek count plus is equal to difference of index comma 0, and then we access the track, which is the new head is equal to request of index. For the last access tracks, seek sequence of length of the seek sequence -1 is equal to head, and then we print the output, and then we print the sequence. So in the main function, I have defined the array that we're going to be using, and we're calling the main function. So now we can So this is the output. So the logic of SSTF is that it tracks the closest disk head, so that we minimize the seek operation. So next we have the first come first serve. So it basically goes in the same order that the array disks arrive. So first I have initialized the size as 8, and I have the function where we're passing the array and the head. Initialize seek count is 0, distance and current track both are 0. So for I in range of the size, current track is equal to the current position of the array. Then we calculate the absolute distance, so distance equal to absolute function current track minus the head, and we increment the seek count. So seek count plus equal to distance, and then our head, we change the head value to head equal to the current track, and then we directly print the total seek operation, and for I in range of size, we print out the array. And in the main function, we have the array, and the head have initialized as 50, and we're calling the function. So we can see that we're getting the